Okay, my name is Daryl Sullins, and today I'll be talking about Experiment 3, spectroscopy of simple molecules. The purpose of this lab was to determine the unknown by searching the similar functional groups, number of peaks in a compound, and the ratio to area. Okay, the elements that were found in the unknown were matched with the elements that were found in the result page of the lab pack, and this was for the functional group. After comparing the elements, a compound was found. The ratio of area was found by finding the numbers that correspond with each peak. IR spectroscopy. Infrared spectroscopy measures the amount of electromagnetic radiation absorbed by a sample. The absorption of a photon in the IR leads to the increase in the energy of the molecular vibration, and the electrons are not affected. Nuclear magnetic resonance spectroscopy measures the amount of electromagnetic radiation absorbed by the sample. This is the same as IR. But the difference is in MIR, the absorption of a photon in the ratio frequency region leads to excitation of hydrogen nucleus. The more complex the molecule, the more vibrations it will have, and this tends to lead to more absorption peaks in the IR and MIR. In the lab, each student was given 3 unknowns. After determining the IR and MIR of each compound, the student had to match the unknown to the correct compound. So out of the 3 compounds that we were given, I chose to talk about 70D. So first we had to determine the functional group, and we did this by matching the numbers found on each peak to the numbers found in the IR chart. For 70D, the compound we found was OH, CH, and that was a single bond carbon. After finding the 70D IR, we were able to consider 4 different compounds, and this was methanol, ethanol, T-butanol, and 2-propanol. Alright, next we had to find the MIR, and after finding the IR, the students then had to find the MIR by searching for the ratio area of the number of peaks. And the number of peaks we found just by counting how many peaks were on the chart, and for this one it was 2, and the ratio area was the number that corresponded with each peak. After finding the MIR, we was able to consider 1 compound, and this was T-butanol. So after matching the IR and MIR to the other data that we found, we was able to just eliminate it to T-butanol. Okay, about T-butanol. It's used as a solvent, so it's used in like paint remover, gasoline, octane, and it's used to produce MTBE and NTBE. Its melting point is 23 to 26 degrees Celsius. Its boiling point is 80 to 83 degrees Celsius. It's very flammable. It's colorless after melting. It has an alcohol odor. It floats and mixes well with water, and it's irritating to the respiratory passages and eyes and skin. So basically, after we found the unknowns, which was O, ONH, and CH single bond carbon, we were able to eliminate it to T-butanol, which has 2 peaks, a ratio of 9:1, so the students were able to conclude that it was T-butanol. And that's my work site.